Hi guys, in this video we'll see how we can solve a relative velocity problem related to a projectile motion. Now the question is just a batter hit the baseball with an initial velocity of v0 which is 100 feet per second directly toward the fielder B at an angle of 30 degrees to the horizontal. The initial positions of the ball is 3 feet above the ground level. Fielder B requires 1/4 second to judge where the ball should be caught and then begins moving to that position with a constant speed. Because of great experience, Fielder B chooses his running speed so that he arrives at the catch position simultaneously with the baseball. The catch position is the field location at which the ball altitude is 7 feet. Determine the velocity of the ball relative to the fielder at the instant the catch is made. So this is the question. Now to elaborate it, let's see how it works. Now assume there is a batter here, just hit that ball and then the ball starts moving just like this one, and then its motion is a projectile motion, and then once the ball flies in this way, then the fielder B just catch it at 7 feet above the ground. If you look over this animation, just the ball flies for a time t, and then the fielder be running for the time t minus 0.25 because he starts his movement after the ball travels 0.25 seconds. And then if you look over this one, the ball is generating a projectile motion, whereas the fielder be had his own constant speed with a rectilinear motion. Then we can see how we can evaluate such types of questions. Normally the ball will have its own velocity, and then the fielder will have also its own velocity. Then once we evaluate each independently, and then we'll see the velocity of the ball relative to the fielder. Now let's see the solution part.
Now let's start from the given part. Then previously, the ball has an initial velocity v0 which is equals to 100 feet per second at the inclinations of theta 30 degree. And then know that time of B, that means for the fielder, it will be time for the ball A minus 0.5 because he starts after the ball launched for 0.5 second. And then you know that the gravity is 32.2 feet per second squared in the downward direction. And then the required parameters are just evaluating the velocity of A with respect to B. If you take out the diagram here, one of the ball launched, then the fielder B will catch it at 7 feet above the ground. And then if this part is just x of fielder B, that means it will cover during the intended time. And then the initial one is given as 220 feet here, and then the initial velocity and inclinations are given, so every parameters are stated here. And then if we just say that if this is the total x which covered by the ball, it can be also x of A. Now let's decompose the system into two parts. That means for the ball part and then for the fielder. Now for ball part, we know that the initial velocity is v0 at an angle theta, and then once the ball flight, it will have the elevation of 7 minus 3, which is 4 feet. Then v0 in the x direction is equals to v0 cos theta, which is equals to 100 cos 30 degree, which is equals to 86.6 feet per second. And then v0 y is v0 sine 30 degree, which is equals to 100 sine 30 degree. it will become 50 feet per second. And then we know that for a projectile motion, velocity in the x direction is always constant. That means Vx is equals to V naught x, and then it will become 86.6 feet per second, which is in the positive x-axis. Now for a constant acceleration, we know that we have three equations. That means V is equals to V naught plus AT, V square is equals to V naught square plus 2A times S, and then S is equals to S naught plus V naught T plus half AT squared. Now by using these equations, we can solve the unknown parameters. Now for the vertical direction, that means for evaluating Vy, we can apply the third equation. If this is equation 1 to 3, that means from the equation 3, if we change this one into the position y, y will become, there is no initial position here, v naught y times t plus half at squared. In this case, the acceleration is equals to negative of the gravity, that means it will be minus half gt squared. Because we know the value of y, we know the value of v naught y, the only unknown parameters will be time. If we substitute the numerical values, we can get 4 is equals to 50 t minus half gt squared. G is set to 0.2 divided with 2 will become 16.1 t squared. Now if you rearrange this quadratic equation into the formal quadratic equation, it will become 16.1 t squared minus 50 t plus 4 is equals to 0. This is a quadratic equation having the coefficients of this is a, this is b, and then this is c. And then we know that t1 and t2 is equals to minus b plus or minus under radical b square minus 4ac over 2a. We know that the value of a is 16.1, the value of b is minus 50, and the value of c is 4. Once we substitute the numerical values, we could get that t1 and t2 will equals to 50 plus or minus 47.4 divided with 32.2, which implied that t1 is equals to 3.02 second, and then t2 is equals to 0.08 second. Since both values are positive, they can be the answer, but which one will be the appropriate answer for the positions when the ball passes over this position? It has no question. This one will be the maximum time, because on the minimum time the ball were just launched and then it was just approaching to the initial position. Once at t equals to 0.08 second, the ball reaches over here, and then after that, when the time increases and it becomes 3 seconds, then the ball reaches the other position. But we know that both values are 4 feet and then 4 feet here too. But the time will be, this one will be t is equals to 0.08, and then this one will be t is equals to 3.02 second. So the appropriate answer for our calculation is when the position that the fielder B catch the ball is at time is equals to 3.02 second. So we'll prefer the first one. Now if we substitute this time over equation 1, we can get the velocity in the y direction. That means Vy is equals to V naught y minus gt, which implies that this can be equals to V naught y is calculated previously, and then it was 50 feet. So it will become 50 minus 32.2 times 3.02, and then Vy will become negative 47.2 feet per second. Then if we will write this part as the velocity of A is equals to Vx in the I plus Vy in the j direction, then it will become velocity in the x is 86.6 in the I minus velocity in the y is 47.2 in the negative j direction. This is the velocity of the ball. And then what is the total distance covered by the ball? It was x. So x can be evaluated from this equation. That means x equals to v naught x plus half x squared. So x is equals to x naught plus v naught x times t plus half ax times t squared. That means if it is in the x component, there is no initial x, and then there is no acceleration in the x because the velocity is constant. That means x will become v naught x times t. So this is equals to 86.6 times 3.02. And then finally, x will become 261.5 feet. And then what about for fielder B? Now for fielder B, we know that TB is equals to TA minus 1/4, which means 0.25, which is equals to 3.02 minus 0.25, and then it will become 2.77 second, and then x of b is equals to x minus the initial distance where 220 feet, so it will become 261.5 minus 220, and then finally x of b will become 41.5 feet. But we know that since the fielder B had a constant acceleration, so x of b is equals to v naught x times, that means for the fielder B, times t plus half accelerations of b times t squared. But since he has a constant velocity, no acceleration, this implies that the initial velocity of b in the x direction means since there is no ny component, we can simply say that v naught b, which is equals to x of b over time. So finally, velocity of b, in the other way, since he has a constant velocity, we can simply say that velocity of b, which is equals to x of b is 41.5 divided with t is 2.77, and then it will become 14.98 feet per second. That means it is in the positive x direction. So that means it is in I direction. Now once we have that, we can evaluate the velocity of A with respect to B. That means the velocity of A with respect to B is equals to velocity of A minus velocity of B, which is equals to velocity of A is 86.6 in the I minus 47.2 in the j minus velocity of b is now 14.98 in the I direction. Now we have two I component, so velocity of A with respect to b will become 86.6 minus 14.98 in the I minus 47.2 in the j. So finally, velocity of A with respect to b will become 71.62 in the I minus 47.2 in the j, and then its unit is just feet per second. This is our answer.